Boom. Hello and welcome back to Calculus 1, section 3.3, Rules of Differentiation. So let's first address the word differentiation. What does it mean? Differentiation means to take the derivative of a function. So it's a process of taking the derivative. So rules of differentiation. So the first thing of the day is that differentiation is the process of taking the derivative of the function. So we say function is differentiable, meaning you can take the derivative at every point. Function is not differentiable at 3, meaning that derivative exists elsewhere. At 3 there is a problem. So this is what it word differentiation means. It's simply an instruction. Now, before we go further, I just want to spend a few seconds on talking about something that it's used in mathematics at large, and that is the notion of operations and operators. Differentiation is an operator where addition and division, let's say, are operations. They are both used to change different concepts. So, if I say operation would be something like plus, minus, times, divide, right, square. So that's the operation. An operation is done between two numbers. So apply to numbers. So if you have 3 plus 7, the result is 10. So you are operating on numbers. In this case, operation between 3 and 7 is plus, it's addition. So operation changes numbers into numbers. Then you have operator. Now that would be derivative or integral. Operators change functions. So operators would change functions. So operations, yes, we can add functions because, you know, functions ultimately give us y values which you can add and subtract and so on. So yes, you can do the operation on functions. But the operator is derivative or integral, and it changes the entire function. So notation-wise, you know all of the rules for operation. You have one number, then plus, then another number, or one number, division, then another number, and so on. Now, notation for derivatives and integrals would be you take the derivative, let's say in respect to x, of a function. So that would be notation for this. And then at the end of chapter 4, guys, this is in 3 weeks from now, we will take a look at the integral of f of x dx, right, which would be that. So these guys are called operators. This one and this one. So those are operators, and they change function from one function to another function, where operations are plugged in between two numbers and they change numbers into different types of numbers. I mean different number, not type. So now with that out of the way, we are going to go and write down a whole bunch of formulas which you choose to memorize, because those are the shortcuts for differentiation, and you do not have to do the long limit procedure. You had one of those limit procedures on your exam. I didn't call it the derivative. I just said work out the difference quotient. Well, that is the derivative. It's a 2.3 calculation. So, first rule would be that derivative in respect to x of a constant is 0. So derivative of a constant is 0. Well, that makes sense because the change of a constant is 0. We discussed that with the graph. So this one says change in constant is 0. That's all it is. Example, the derivative of 3 is 0. The derivative of pi is 0, and so on. So anything you can come up with, the derivative of 4/3 is 0. So if you are taking derivative of a constant, it's a 0 because each one of these will graph as a horizontal line. There is no change in the horizontal line. Therefore, the derivative is 0 because derivatives measure the change. So that's our first rule, and the first rule states that the derivative of a constant is a 0. Second rule, which you are going to memorize, is extremely important and very frequent rule that you will use, and that is the derivative of x to the n. So derivative of x to the n, and that one is giving us n x to the n minus 1. Now, this rule includes a lot of stuff. It includes polynomials, radicals, and basic rational functions. Well, rational functions. And I have to give you example of all of these, and then we are going to see even more. So first, I'm going to ask you what is the derivative of x to the 8. You will quickly pick up that n is equal to 8, and you will just write it's n, x to the 8 minus 1 is 7, and you're done. So that's the answer, 8x to the 7. Now, you have an option to memorize the formula and do that, or good luck foiling this x to the n, right, to the 8 times to do the long limit procedure from 2.3. You can, right? It's just going to take 30 minutes to foil all of that. So, again, it is your choice to memorize the shortcut. Otherwise, it will be the limit of x plus h to the 8 minus x to the 8 divided by h, then foil x to the x plus h to the 8, which is right long expression, and then work it out from there. Yes, you are going to get 8x to the 7, but again, after 30 minutes. So we are choosing to memorize red equation because it quickly deals with these things. Now, obviously, if it's x squared, it's just 2x, and we did that in class with the limit, so we know it works. I mean, it's been hundreds of years that it's been working, so we're fine with all of these rules, right? It's not invented yesterday. Now, that's polynomials. I don't care which exponent you put there, whether it's a square or 8, or you put 13th power or 275. Whatever you put as the exponent, it's always going to be minus 1, and you're done with that rule. Radicals. If you remember from your high school or previous course in algebra, so here is the blue star over here. Blue star says that if you have 1 over x to the n, that is actually x to the minus n. The same rule has to apply. You see that? So if I ask you to find the derivative of 1 over x to the 6, you will first rewrite this as x to the negative 6, and then just use the same rule in red. No need for a different rule. Yes, the function is completely different. It's no longer a polynomial. It's now rational function. Oh, wait, I was supposed to put the blue square over here. And then blue square, blue star, whatever it's called. And then radicals are different. So rational function is 1 over x to the 6. So you copy it, and then again, you drop the power down, that's negative 6. And then you subtract 1 power, that's going to be now x to the negative 7. So the answer is negative 6 divided by x to the, right? We like to leave positive exponents. So we are going to stuff it in the denominator again. So the procedure is a little bit longer, but it's great that we don't have to learn the new rule. It's the same rule. We just use the basic algebra knowledge that everyone should have by now, that if the exponent is positive in denominator, it becomes negative in the numerator. If it's negative in the numerator, it becomes positive in the denominator. So that's the basic algebra rule that you study in a course in high school. And finally, radicals. I'll use the red on that one. For radicals, we remember that the nth root of x is actually x to the 1 over n. So I can still write that as the exponent. So if I have to find the derivative, like we did in class, right, of square root of x, well, I'm going to rewrite that as the derivative of x to the 1/2. And then I'm going to drop the power down, and then half x to the negative 1/2, and then use algebra to put it back together, which is exactly what we had in class. If you flip a few pages back, right, to 3.1. I worked this out using the long limit method. It took half a page. Now it takes 2 steps because of the shortcut formula we learned. So as you can see, this one rule addresses a lot of stuff. You can take derivatives of polynomials, you can take derivative of rational functions and of radical functions. Now, guys, I'm going to ask you to solve 3 questions as exercise. So the first one is going to be the derivative of x to the 15th power. The second one is going to be the derivative of 1 over x to the 10. And the last one is going to be the derivative of the 4th root of x. So you will be using the same formula we just covered, which is n x to the n minus 1. You just have to use algebra to rewrite exponents appropriately. Other than that, you should be good to go. People would say that the major thing in calculus would be you subtracting 1. Wow! Huh? So advanced. Calculus is hard. No, it's not. You just subtract 1 in that class. That's all. Exams will be returned on Monday and Monday alone. If you are not in class to pick up exam on Monday, you will have to make arrangements and stop by my office or follow me after class to my office, because I will not be dragging these every day to class, you know, whenever Your Majesty decides to show up and pick it up. So, Monday, B class. Let's work out these together. So the first one will drop 15 down, as the formula says, and then subtract 1, so x to the 14. The next one I have to rewrite first. You don't, in the future, you can just write the answer down, right? But now we, take our time to make sure everything works fine. So it's negative 10, x to the negative 11. So that's negative 10 over x to the positive 11. The last one I have to rewrite as a quarter in the exponent. So x to the 1/4. and that drops 1/4 in front, x to the negative 3/4. So this is going to be 1/4 times x to the positive 3/4 as the exponent. So it's very straightforward for all of these, obviously only if you know the formula. If you don't know the formula, then you have to do the limit, right? Now in blue, we have some rules. One rule says that if you have a function multiplied by a constant, you can kick that constant in front of the differentiation, worry about the function, and then multiply that constant back later. So to write that formally, we will say that the derivative of c times f of x is going to be kick the constant outside and then just worry about the derivative of the function. Right, so that's one of the rules. Where can we use this? Well, say you have the derivative of 3x to the 6. You will kick 3 in front of the differentiation and just focus on differentiating x to the 6. Copy the 3 times 6x to the 5 for the answer of 18x to the 5. Now, I understand that by Monday, maybe, even by Monday, you will go from first step exactly right to the last step, which is fine. And you are supposed to do that, right? It just depends on the amount of homework and practice that you put in between now and Monday. But it is okay, right, to do this particular rule in your head every time, because you will just say 6 drops down, 6 times 3 is 18, 6 minus 1 is 5. So it's a very quick way to get to the answer without writing these intermediate steps here. Sure, write them if you need them, right, to learn, but not pretty much, everyone in this class will very quickly go directly to this because you will be doing it so much that, right, it's going to be there. The next rule is also very important. It's actually 2 rules in one, which says that the derivative of sum or difference of functions is so the derivative of sum or difference of a function is the sum or difference of the derivatives. So if I have f of x plus or minus g of x, it works for both. The rule states that you can take the derivative of f of x and add or subtract whatever you had, add or subtract the derivative of g of x. So these are the 2 rules that cover linearity, actually. You do not have this type of a rule for multiplication and division. The next section, those of you who did class prep, you know that the next section will address when this is either multiplication or division. They're separate formulas. So this type of situation where you can do them individually, that's only for addition and subtraction. We're going to have full-blown formulas for product rule and quotient rule for multiplication and division, and that's going to be on Monday. Monday we're going to do 3.4 and 3.5 to keep on time with the schedule. So now, what is this rule good for? Well, how about if I am trying to take the derivative of x cubed minus square root of x, right? Now, the second rule in blue, right, the last blue line, tells us that each one of these is to be done independently. So we know that the first one is 3x squared, and you put the minus sign, which is already there, and now you have 1 over 2 root x. We know that from before, right? We took the derivative of square root of x right here, and we know what it is. We will memorize that one as well, because it's just around all the time. So the first rule up there tells us that we can kick the constant outside. The second rule tells us that if we have addition and subtraction, so we have multiple terms in the function, each term will be differentiated separately. We don't have to worry about any other terms. We just do one at a time. Now, these two rules combine nicely into a longer problem, so most of your homework should look like something like this. So let's say you have 3x squared minus 5x plus 6 minus 1 over x cubed. So if you look at this problem, you actually have to employ all of these techniques that we learned so far. First off, you have 4 terms. That means there are 4 separate derivatives to be taken. First 2 are polynomials. The next one is the constant rule. And the last one is the radical function, which also uses the same rule like for polynomials. So when you do this one by one, the first one is going to be 6x, right? Because 2 drops in front. 2 times 3 is 6. And then 2 minus 1 is 1. So x to the first power, which is just x. The next one is just 5, because the exponent on x is 1. When that drops down, 5 times 1 is still 5. And then exponent of x becomes 1 minus 1, which is 0. X to the 0 is 1. So we are getting 5 times 1, which is 5. So linear terms will just pick up the coefficient every time. Plus 0, which is derivative of a constant, right? 6 is a constant. Derivative of that is 0. That was the first red rule we had today. And then we have the derivative of this negative 1 over x cubed. Now, if you have the derivative of negative 1 over x cubed, you know that you are supposed to rewrite that as x to the negative 3, right? So negative 3 will drop in front, and there will be x to the negative 4, but there is a negative in a problem, so it's plus 3x to the negative 4. And now we just rewrite all of this so it makes sense. So I have 6x minus 5, don't have to write the 0, plus 3 over x to the 4th power. And that would be the derivative. Can you do this using the limit definition? Sure. It's just going to take a while. But it can be done. Right? It can be done. Now, we are going to have, as I said, separate rules for multiplication and division. So none of that stuff should be in the mix right now. However, some of the homework exercises will try to trick you. Make sure you are doing the algebra. Don't do calculus, do algebra. So say that you have the derivative of 3x to the 6 divided by x squared. Let me write here in blood. Do the algebra. Combine x's, okay? Combine x's. So this problem is actually just 3x to the 4th. And we are going to get 12x cubed as the answer. Do not take independent derivatives. It doesn't work. For division, we are going to learn quotient rule on Monday. And then we can actually use quotient rule to solve this and get the same answer, but that will be overkill. We don't have to do that. It will be overkill to actually use the quotient rule on this problem, because quotient rule is a procedure. It takes time to take the quotient rule. If you can solve the problem using the algebra and a basic rule, that is much better. I will also outline the issue with students not recognizing, let's say, 3 over x squared, right? And then they spend time doing the quotient rule. This is the basic rule times the constant 3. You kick 3 in front of differentiation, and you differentiate x to the minus 2. There is no need for quotient rule. Quotient rule will only be used when you have different functions that you can't divide, right? It's technically a sledgehammer, and there's no need to use a sledgehammer if you're trying to put up the picture on the wall. I use a small hammer. Even a framing hammer should be too much, right, for that job. So the idea is to use appropriate tools to save the time. For both of these problems, would quotient rule work? Yes, we'll see that next class. Yes, it will work, but it's overkill. You can work out these problems using algebra and then just have the solution. So this is going to be 3 times negative 2x to the negative 3 for the total of negative 6 divided by x cubed. And that would be the derivative of the last problem. We have one more rule to learn, and then just talk about higher order derivatives, and we are done. So it seems that we will be probably done before the time. The last rule that you need to memorize is that the derivative of e to the x is e to the x. Now we'll have modifications on this later in a course, but for now we are just learning that the derivative of e to the x is itself. It is the only function which returns itself as a derivative. So this is unique, okay? Special. The derivative and the function are the same function. Now, there is a modified version which you need to solve some of your homework problems, but we are going to actually learn why is this modified version what it is, I think in 3.7 or something like that. So you need to have this memorized just for a little while, but you know, so that you can do your homework. But in 3.7 we are going to have much more powerful technique. So modified version of this one is that the derivative of e to the ax is a e to the ax. So that's the modified version. I am going to box that one as well, just blue, and I'll point like this and I'll say homework, okay? Because in homework you are going to run into a question which says find the derivative of e to the 5x. And that is 5e to the 5x. Now, the rule that actually we are using in this case is called chain rule. And we are going to have the similar stuff happening with the trig functions and other functions. But, as I said, the rule that you must know for purposes of surviving calculus is the one that is boxed in black. Now, the other one in blue is broader concept, and it's actually something that we will study in detail later, so you just need to have it memorized for a short while. Great. All of this that we did so far are just a bunch of formulas which you have to memorize in order to efficiently go through process of differentiation. Why would you want the process of differentiation efficient? Because you want to find the derivative quickly, because the derivative, the slope of the, right, it measures the change. And your goal is to measure the change of money in the account, the change of population, the change of velocity and whatever, right? So the goal of whatever your discipline is, you're sitting in this class for a reason. There is application in your field. Well, unless you're marketing, I can't really see. That is one that lately I've been getting a lot of marketing students, and I'm just asking why. There is statistics, and just be happy with it. Anyway, so certain types of business, like the higher end business, where you have to understand certain calculus concepts, I will go through 4 or 5 examples throughout this course that will be just pure business analysis, where you will understand why business majors, like the upper level business majors, have to take calculus. It makes perfect sense. But for most of the non-engineering, not science, not chemistry, right? Statistics is what you need 99% of the time. So yeah, that's that. But okay, so going back to this, we have, I think, 5 formulas that we need to know. Derivative of constant is 0. Constants do not change, therefore the change is 0. The derivative that covers the formula, which covers polynomials, radicals, and rationals, that's that one. Then we have the 2 rules, one that kicks the constant and the other one that works with the exponents. And finally, the exponential one. Now, one type of a problem that will be present in every section of Chapter 3, and it will be present on all of the exams from now on, which means exam 2, 3, and the final, is the problem which says, find the tangent line. Right? Find the equation of the tangent line. So let's do one of those now, and we will actually be working on one of these every single class because it fits. So as long as Chapter 3 is on, this problem will be on the board at least once a day. Find the equation of the line, of the tangent line. Guys, this is guaranteed 100% on your exam. 2, 3, and final. Find the equation of the tangent line at x equals 3 for f of x equals x squared minus 2 over x. So I have a function. I don't need to graph this now. We can graph it later and see if what I have works. So the way I'm going to do this is, we know that the slope of the tangent line is obtained from the derivative. So I'm going to find the derivative first, right, which is the derivative of x squared minus 2 over x. The derivative of x squared is just 2x. And then we have minus 2 times, well, it's plus 2 over x squared. Okay, so plus 2 over x squared. So that's the derivative. You can use the rules that we, right? You are taking the derivative of negative 2x to the minus 1. So you copy negative 2, you drop down negative 1, you have x to the minus 2, which all of that is, when you use the algebra appropriately, it works out to be that. So you rewrite the problem first. You can do this in the margin of the page until you get used to these things and start skipping these steps. So you rewrite the problem, then you know you copy the constant, you drop the exponent, and then you subtract 1. So it goes negative 2 times negative 1 is positive 2, and then x to the negative 2 goes downstairs as x squared. So now I have the derivative. Once I have the derivative, slope of the tangent line is the derivative computed, so your derivative computed at the point they are giving us. So I need to compute 2 times 3 plus 2 times 3 squared. So this is 6 plus 2 over 9. And the slope that we are looking for, times 9, 54, 56. So it's 56 over 9 when you add fractions. Right? Now, I need a point. 3 comma what? So that I can find y equal mx plus b. Okay, so to find y, I will quickly calculate, let me put it this way, y is equal to f of 3, because we compute original function at the point to find the y value. So that's going to be 3 squared minus 2/3, which is 9 minus 2/3, and that's 25 over 3, right? When you find the common denominator, 9 times 3 is 27, minus 2 is 25. So we get this. Great. So now I have that the slope is 56 over 9, and the point is 3 and 25 over 3. Who picked these numbers? So now you can use either y equal mx plus b, right, because you have x, y, and m, and find b, or you can use y minus y1 is equal to m times x minus x1. So whatever. In general, I use the one on the left. I could use the one on the right too. It's just more writing, so right. So my y is 25 over 3. My m is 56 over 9, and then that's times 3 plus b. These guys cancel nicely. So now I have that the b is equal to 25 over 3 minus 56 over 3, which gives me, when I subtract this, is a 31 over 3. So the tangent line is given by y equals 56 over 9 x plus, no, minus, this is a negative number because I have 25 minus 56, minus 31 over 3. There we go, much better. That's the answer. So find the equation of the tangent line. Well, it's the procedure. Now, every section of chapter 3 is going to have this problem in it. Tangent line is the central problem of Calculus 1. Calculus 1 focuses on derivatives. Calc 2 focuses on integrals. So, in Calculus 1, you are looking for the derivative. Derivative measures the change, so you want to be able to find the tangent line, the slope of the tangent line efficiently. So, the procedure will always be the same. Step 1, find the derivative. Step 2, compute the slope. Step 3, if you don't have it, compute y. Step 4, get b using whatever formula you want, and you have m and b to compile the tangent line. This tangent line changes as soon as you change the location of your x. We did this for x equals to 3. So this is the tangent line at x equals 3. If I want to go and figure out x equals to 4, I have to redo the entire procedure, because it will change the slope as soon as the slope changes, right? Because now we will be computing at 4 rather than at 3. Slope changes, y value changes, therefore everything about this line changes, right? You will have different number for both locations if you change the location. Now, that should make sense. Now, what I'm going to do is show you the way in which you can check your work as you are looking for these tangent lines. It is very important for you to prove to yourself every time that you are doing a good job. We can use Mathematica or Wolfram Alpha, which is the part of that software. So, you have a free version from RVCC. And once you install the Mathematica on your computer for free, you have Wolfram Alpha for free, because it's the part of that software. Otherwise, you have to pay on the website, right, on a monthly basis or whatever it is. Or I think if you have a tablet, it's a one-time charge. Or for cell phones, it's one-time charge of like $5-6 or whatever it is. And if you do it on the website through the computer, then it's a monthly charge of $3 or $5 or whatever, which makes no sense, but that's what it is. Okay, so what I'm going to do now is I'm going to just talk to it. Graph, and I'm going to give it these two equations. I want to see them just, we discussed the word kiss at 3, right? So the curve of whatever the function is and a straight tangent line, they have to touch at x equals to 3. So what I'm going to say, graph x squared minus 2 divided by x and and now I go and I write the tangent line. And 56 divided by 9 times x minus 31 divided by 3. And then we wait. It gives you the functions. You try, right? You see if everything is correct. And if it is, it's a bad graph, but you can see at 3 right there. It's a tangent line. Wish I did this for 0.4, but I haven't. For 0.4 would be nicer to see on a bigger curvature. But you can see it, and you can always do the control plus to enlarge it and see it even better. But the idea is that at 3 over here, right, these two lines are touching each other at a single point. And that's the procedure for the tangent line. So next, on Monday, we still have one more concept, it's short. On Monday, we are going to learn how to deal with the product rule. And then I will say, find the equation of the tangent line, and the function that is given will have product rule inside. Then we're going to do the same for quotient rule, and same for chain rule, and implicit differentiation, and logarithmic differentiation. What is changing in chapter 3 is type of a function and the way you take the derivative. What stays constant is the procedure for tangent line. So from section to section to section, the only thing that it changes is this line here, because you are either doing, well, whatever is changing is this line here, which is what rule do I use to take the derivative? The rest of the problem stays unchanged from section to section, and it will be in every section we cover in chapter 3. So make sure you know this procedure very well. Now the last thing in this 3.3 section is higher order derivatives. You know how there are levels of hell? Yeah, we start right there, okay? So now we have the same situation with derivatives. You take the derivative, and that is the first derivative. Then you can take the derivative of that derivative and get to the second derivative. And then the third and the fourth and the fifth, and you can go as far as you have. Now, generally, applications that we have in the world around us go up to third or at most fourth derivative. I've never seen application with more than 4 derivatives taken. But there could be some that I don't know of, right? We can go with derivatives indefinitely. So let me give you an example. If I start with f of x, let's say it's x cubed, then the first derivative, which is just one tick mark, we could say f prime, right, would be 3x squared. And we just use the basic rule we know, right, to take this derivative. Now, if I want to go to the next level, I will take another derivative of the first derivative, arriving at the second derivative, and now this one is 6x, because the derivative of x squared is 2x. 2x times 3 is 6x. So all I did is I took the derivative of the derivative, and then what I got is the second derivative. The third derivative will have 3 tick marks. Surprise, right? And as we take the derivative of 6x, we get 6. For the fourth derivative and on, notation changes into the numbers inside the parenthesis. And now all of the next ones over here will be 0 because we are working with the polynomial. Right? The polynomial will eventually die out because it eventually will hit a constant, and then in the next derivative, that derivative of the constant is 0. So polynomials always die out. But there's just polynomials. No other function dies out, right? Remember that those that had x squared in the denominator, the derivative of that one had x cubed. Right? Those will be picking up. So only polynomials die. What is the 140th derivative of e to the x? E to the x, right? That one doesn't change. The derivative of e to the x is e to the x. And if you go and you take the derivative 140 times, it's still e to the x. What is the 140th derivative of e to the 2x? Well, that 2 drops in front 140 times. So it's 2 to the 140 e to the 2x, right? You can compute that as well, right? It's not a big deal. We will see also trigonometric derivatives, right? Sine, cosine, tangent, and all of those guys, right? Those will not die also in the higher order derivative. So it's easy, right? You just go and you take derivative after derivative. The only annoyance is that if I'm asking for the third derivative, there is no shortcut. You have to get the first, and then you have to get the second to get to the third, right? You don't have an option there. You must do it. So that's that part. You must do all of the derivatives leading up to the derivative you actually need. That's the downfall. Other than that, it's easy, right? You just keep taking derivatives down the line. Monday, 3.4, 3.5. Enjoy your rain over the weekend. Which just means you're going to double up on homework and, right, all of that stuff. You're going to study calculus 3 times as hard as you would if it wasn't raining. You know what? I hope it rains every weekend. Only till 4th of July. Then it can start nice. All right? What happened?